1984, the world's worst industrial accident happened here. This factory released a chemical cloud that killed thousands of people in just a few terrifying hours. The accident happened because of a chemical reaction that took place in this tank. A reaction that led to one of the biggest man-made disasters in history. What happened here were seconds that shocked the entire world. Disasters don't just happen. They are the result of a sequence of events, locked together in time. The science behind what went wrong is hidden in these seismic seconds. The city of Bhopal lies on the edge of a large lake, almost exactly in the center of India. It is the capital of the region and is growing at a phenomenal rate. With a population of over 1.4 million, this is a busy, bustling and vibrant place. But on the 3rd of December 1984, Bhopal was the scene of a catastrophe on an unprecedented scale, as at least 3,000 people choked to death in a cloud of gas. Many times that number survived that night, only to have their health and livelihoods wrecked, while compensation claims and legal battles continue to rage. The killer chemical was something called methyl isocyanate, or MIC for short, and it came from this plant built at the edge of the city. It has been sealed off from the outside world for over 16 years, preserved by the Indian government as it investigated the cause of the disaster. Perhaps the most chilling artifact here is the actual vessel from which the poison escaped, now dug up from its original underground location. The MIC was released due to an unforeseen and uncontrollable chemical reaction. To explain how it is thought to have happened, several workers at the factory agreed to revisit it for the first time since that terrible night in December 1984.
I joined Union Carbide in 1971, where there was actually nothing anywhere. There were just a few small plants. By 1983, we had built this up into one of the most efficient and safe chemical complexes in India. But standards had been deteriorating for some time. And I was being shunted from department to department. I was in safety, then I was transferred to maintenance, at which point of time I decided to quit. In my leaving interview, I mentioned to the management that they are in for trouble if they don't pull up their socks. And that's exactly what happened a year later.
Built by Union Carbide, a giant multinational corporation, the factory manufactured pesticide, desperately needed as India struggled to produce enough food to cope with a population explosion. 7, as the pesticide was called, works by attacking the nervous system of insects, and its production requires some very dangerous chemicals. On that dreadful night in December, those chemicals got out of control. The first person to notice that something was wrong, something that was to lead to the biggest chemical accident in history, was a technician called V.N. Singh.
This was our control room, but it looked very different then when it was all quite new. I ran over to the pressure gauge and it went right off the scale.
Outside, 40 meters away, the storage tank was about to deliver its deadly load. It was 15 minutes past midnight. The contents of this tank represent the triumph of profits over safety. To understand how this happened, we need to wind the clock back 4 hours. The events that led to the contamination of the tank are still disputed, but the findings of the Indian government point to a disaster that started at approximately 8:15 that December evening, when a plant worker began some routine maintenance. He connected a water hose to part of the plant's maze of pipework. Keeping the system clean was vital, as contaminants could easily be formed during processing. Dirt was supposed to flush out of the system through drainage nozzles, a process that would sometimes take hours. Almost immediately, something began to go wrong. He had unwittingly started a sequence of events that would end with the deaths of thousands.
The chemical industry does use a wide range of hazardous materials. For example, we might use sulfuric acid in the manufacture of detergents. The detergents themselves are not harmful, but the sulfuric acid is potentially dangerous. Likewise, there are intermediates that go into the manufacture of shampoo, which are made using cyanide. If you're going to carry out a process of that type, you need to be careful. And clearly at Bhopal, they weren't.
The disaster's origins lay in the particular way in which Union Carbide chose to make Sevin.
Chemistry is a little bit like cooking. If we're trying to make a molecule like Sevin here, what we'd like to do is to buy the ingredients off the shelf. We don't want to have to make any complicated intermediates if we can possibly avoid it. The molecule here, Sevin, is made up of this part, which we can buy essentially off the shelf. More problematic is putting this part on here. The process that Union Carbide used at Bhopal started with the reaction of carbon monoxide and chlorine to make phosgene.
Phosgene provided one of the crucial building blocks for methyl isocyanate, or MIC, which in turn became a component of the Sevin molecule. Phosgene had killed a worker 3 years earlier, in a foretaste of the agony still to come.
Ashraf Khan, a maintenance worker, was working in this area. He was wearing a breathing air hood and only dungarees below that. Phosgene splashed onto him and soaked his dungarees. He panicked and he ran for a shower this way. He came here, he removed his hood. The phosgene which had penetrated his clothes evaporated. He inhaled that and he died in hospital a few days later.
Phosgene became infamous when it was used in warfare, and most infamously during the First World War. It's relatively insoluble in water, and when released it creates a white cloud quite close to the ground, and I understand smells of new mown hay. Because it's insoluble, if you breathe it in, it won't get absorbed at the upper end of your respiratory tract, but will reach the furthest, deepest parts of your lungs. This is a picture of those deep parts of your lungs. It's these membranes that phosgene damages. If you breathe in phosgene, these membranes will be destroyed and blood will flood into your lungs. In effect, you will drown in your own blood.
As phosgene was so lethal, the plant only ever stored enough of it to satisfy 1 day's production. That way, even if there was a release, the scale of the problem would be minimal. But phosgene is merely one ingredient for the chemical that was to kill thousands.
The next step in the process is to put this group on. You can do that in a number of ways. You could add on this bit and then that bit, but Union Carbide chose to do it in one go, a single reaction. Now that's cheaper and potentially a lot cleaner, so it has some advantages. The downside is that the chemical we need to do that is methyl isocyanate, which is extremely dangerous.
In contrast with phosgene, MIC was stored in 3 vast tanks, originally buried in a concrete bunker near the edge of the plant. 40 feet long and 8 feet in diameter, each was capable of holding 42 tons of the potentially lethal chemical. Where phosgene was a famous killer kept in small quantities, MIC was stored on a scale that would kill thousands. 8:45. The pipes that were being washed started to become choked with the dirt being carried by the water. The nozzles became blocked and water began to back up, flowing into one of the main pipe systems that ran throughout the plant.
MIC is very handy stuff. It reacts to produce particular molecules that we probably couldn't reach easily by other chemistry. So it's very useful to the chemist. He can build things in a way that he wouldn't otherwise be able to do. It's also reactive, which means that things that happen fast. We don't need very long reaction times, and we tend to get perhaps cleaner chemistry, fewer waste products. However, the reactivity is a problem. It means that it's going to react with a whole range of things it might come into contact with. Water, for example, or worse still, people.
Keeping MIC apart from water is vital, because if the two liquids mix, anybody nearby would be in serious danger.
MIC is a highly irritant gas. It has two important physical properties that make it particularly unpleasant. The first is that it's very soluble in water. And the second is that it vaporizes or boils at a temperature almost exactly the same as the body. This means that if you inhale MIC at low concentrations, it's going to affect in the first place those parts of your body that are wet, which will absorb the MIC. That's your eyes, your mouth, your throat, and your upper airways. At high enough concentrations, it'll get the whole way down to that part of your lung where oxygen is transferred into your bloodstream. And very similar to the effects of phosgene, if that part of your lung is damaged, then serum will flood from your bloodstream into your lungs, and you'll die from a sort of internal drowning.
With water flooding the pipes, time was running out. The tank should have been protected from contamination, but a catalogue of failures was about to have the most terrible consequences for the people of Bhopal. The tragedy at Bhopal happened when some 35 tons of a lethal chemical called methyl isocyanate reacted with water and vaporized. Thousands of people in the shantytown that surrounds the plant were gassed, dying in the same horrific way that soldiers were killed in the First World War. The disaster was due to an amazing combination of circumstances. Had each happened on their own, the accident would never have occurred.
In terms of designing chemical plants, there are really two sorts of safety. One is designing the plant to be safe in the first place, and the second is operating it safely. And at Bhopal, there were problems in both areas.
3 hours to go until the catastrophic release. The first of many hundreds of litres of water found their way from a routine cleaning operation into the main pipe system that ran throughout the factory. It should have been impossible for the water to get very far, but mistake number one had already been made. A safety procedure existed to isolate sections of pipeline before they were cleaned. A simple piece of metal called a slip blind is inserted and the bolts done up tight, achieving an impenetrable seal. Incredibly, this procedure was often ignored at Bhopal.
To install a slip blind like this would probably take about 2 hours, and you would have had to wear a lot of protective clothing, because when you undid the bolts of these flanges, the possibility of chemicals splashing onto you would be there. If one of these small pieces of steel had been inserted into the process pipeline, in all probability this disaster would not have happened.
By 9:30, the water was able to travel freely through the hundreds of meters of pipe that separated the main plant from the MIC storage area and its deadly content. The disaster could still have been averted, however, had the gauges in the factory's control room been trustworthy.
When this plant was designed and installed, the instrumentation here was probably state of the art as far as India goes. Over the years, lack of maintenance contributed to the instruments giving faulty readings from time to time, which probably led to the operators and to the staff not taking the readings very seriously.
MIC is kept under pressure with inert gas to stop anything from getting into the tank. But for 6 weeks, the pressure gauge had read virtually 0. It was presumed that the gauge was faulty. In fact, there was a leaky valve connecting the tank to the plant's main pipe system. If gas could get out, then water could get in. By approximately 10 o'clock, the contamination had started.
The reaction of MIC and water generates carbon dioxide as one of its products. It also generates heat. Of course, the heat starts to warm the mixture. It's an exothermic reaction, as we call it. What I'm going to do is a similar reaction that obviously uses much safer chemicals. This material is going to behave rather like the MIC did. The material I'm adding is in effect the water that came into the vessel. We add that, and as you can see, gas bubbles start to form.
Water is denser than MIC, so it falls to the bottom of the vessel. The first part of the reaction takes place where the 2 layers of liquid meet.
So this looks exactly like the MIC water interface would. We're generating bubbles at the boundary between the 2 liquid layers. But the key issue is the heat. This heat heats up the reaction mixture. The temperature rises, and when the temperature rises, the reaction speeds up, and in turn generates heat even faster. It's what we call a runaway.
Even with water in the tank, it should have been possible to control the situation. MIC has to be kept cool, and the tanks were housed in a concrete bunker, insulating them from the fierce heat of central India. There was also a cooling system controlled from a purpose-built refrigeration plant. The senior management, however, had decided to switch it off.
This wasn't running on the night of the tragedy. In fact, it had been off since May '84. The coolant inside had been removed and it was permanently disabled.
Switching the refrigeration off was an insane thing to do. These reactions, these exothermic runaway reactions, take place when we're generating more heat than we can remove. The refrigeration system was there to remove heat. Switching it off made this incident much, much more likely.
Incredibly, another safety device had been bypassed, in defiance of Union Carbide's own operating instructions.
See now the reaction is getting quite enthusiastic, getting some bubbles, some droplets of liquid coming out of the top of the vessel, and if this were an industrial scale vessel, we would have a significant emergency on our hands.
At Bhopal, there was a machine purpose-built to deal with toxic gases, a device known as a vent gas scrubber.
This is the vent gas scrubber we had at Bhopal. It works by neutralizing toxic gas before releasing it into the atmosphere. On the night, though, it was switched off for maintenance.
Even if this vital piece of equipment had been on, it was too small to cope with the quantity of MIC that was now out of control.
This is really bubbling violently now. As you can see, lots of gas being generated, and of course at Bhopal the whole thing was happening on a scale 100,000 times bigger. There's absolutely nothing that can be done to slow this down. Heat is being generated so fast that on an industrial scale we cannot remove it quickly enough to stop the reaction. This is the worst nightmare for a chemical plant operator. This is a disaster.
V.N. Singh was working at the plant that night, and it was his duty to check the area where the pipe washing had started some 4 hours earlier. By this time, midnight, water was flowing once again from the drainage nozzles, but he noticed that something was wrong. The disaster was just minutes away.
When I got here, I saw water running out of the bleeders, but my eyes started to hurt. This was quite common at the factory, but that day it was very, very bad, so I ran to the control room.
What VN Singh saw when he got to the control room about a minute later was the final stage of a chemical process that had been underway for over 2 hours.
At a molecular level, things are happening extremely fast. As the system warms up, a second reaction kicks in, trimerization, a reaction between 3 methyl isocyanate molecules that forms a stable molecule and generates more heat.
As each bond is made, energy is released. Now the MIC molecules were able to react with themselves. All 42 tons of the material were free to generate heat almost simultaneously.
The reaction's getting very violent at the moment. Material's starting to leave the top, lots of gas being generated, bubbles of liquid leaving. Right now, with the equipment they had at Bhopal, there was absolutely nothing that could be done to save the people.
So I came running out to tank E610, and even though it was underground, you could hear a terrible rumbling noise, and the concrete started to shake and crack.
The tank was now in serious danger of bursting, but it held. Instead, a pressure relief valve blew, and the gas was on its deadly way. It travelled to the main plant structure, through the useless vent gas scrubber, and then out. The gas was carried away by a southeasterly wind, clear of the plant, but directly over the sleeping city of Bhopal.
When I started working for Carbide in 1971, it was one of the proudest moments of my life because I was selected to work for Union Carbide. But after that disaster, I'm ashamed now that I was ever associated with a company which did not manage to live up to its name and reputation in India.